Good afternoon to everyone. Today class is textures of igneous rocks. Okay, shall we start? Right. Okay, textures of igneous rocks. Right. You see here textures of igneous rocks. So igneous rocks. So these are made up of mineral crystals or grains. So those are formed due to the crystallization of magmas. So as magma, so that is move upward, right? Move upward. So minerals start crystallization from them due to cooling process, right? So if the solidification that is complete with the earth in the rock, it will be composed of crystals, right? Composed of crystals. So, but when these magmas, right? These magmas are erupted at the surface of the earth, right? So along with the crystals, so these crystals already formed inside the earth. So they cool somewhat rapidly, and sometimes it is very rapidly under such conditions, formation of crystals. So that is not favored in here, right? So as a result, the remaining liquid solidifies into a mass that is, which is not crystalline. So this is non-crystalline igneous material. So that is called glass, right? GLASS. So what is the mineral composition? Mineral compositions are minerals are formed from magmas. So those are called pyrogentic minerals, right? Right? Pyrogentic minerals. What is the pyrogentic minerals? So minerals formed from magmas. So that is called pyrogentic minerals. So as silicates, so those are the most abundant silicates. So remember this word silicates. So this is the important things. So these silicates are the right. These silicates are the most abundant minerals, right? Most abundant pyrogenetic minerals. So the study of crystal structures of silicates, that is reveal the tetrahedra. So tetrahedra. So this is the form of crystallization, crystal form, right? So this tetrahedra with a silicon atom at the center and 4 oxygen, right? 4 oxygen. So these 4 oxygen atoms at the 4 corners. So that is called SiO4, right? SiO4, right? So this is oxygen 1, 2, 3, 4. So this is silica, right? So this is called SiO4 tetrahedra. So from the fundamental units of the silicate structure. So we have some different types of silicate structures. Those are produced due to the linking of the this SiO4, this silicate tetrahedra in different ways, right? So based on the crystal structure, so those silicate structures are classified some types. So you see here, right? So first one is nesosilicate, right? Nesosilicate. So for example, in nesosilicate, that is olivine, right? Olivine. So olivine. Second one is sorosilicates, right? Sorosilicates. So this example is epidote, right? Epidote. And third one is cyclosilicates, right? Cyclosilicates. So this example is beryl, right? The next one is, fourth one is inosilicate, inosilicate. So these examples is enstatite, and also anthophyllite, right? Anthophyllite, right? So last one is, that is fifth one. So that is tectosilicates. So examples is quartz, orthoclase, and lucite, Lucate, right? So these are the some of the crystal structures. Those are silicate structures, right? So first one is nesosilicate and sorosilicate and cyclosilicates and inosilicates, and last one is tectosilicates. So these are the silicate structures types. So those are 5 types, right? So all these five types minerals, so those are never found to occur in a single igneous rock, right? So the minerals of low silicates are like this olivine, right? And lucite. So these are never occurred with this quartz, right? Never occurred with this quartz. So these minerals are restricted to igneous rocks, that is low in silica. When most rocks are multi-mineral mineralic, so these are rocks which are composed of 3 or 2 minerals, or even 1 mineral also, right? So some of the pyrogenetic minerals, so that is commonly found in the igneous rocks, right? So what is that? Okay. So examples, SiO2, right? SiO2 minerals. What are the SiO2 minerals? That is quartz, right? Tridymite. Also tridymite. Tridymite. And also pyroxenes, right? Pyroxenes. So those are hyperscene, bronzite, right? Bronzite and diopside, and also augite and agarine, right? So these are the examples. And feldspar, right? So pyroxene completed feldspar. So feldspar, for examples, Examples are plagioclase feldspar, and orthoclase feldspar, and anarthoclase feldspar, and also microclase feldspar. So these are the feldspar group minerals. And also next one is amphibole group, right? Amphibole group. So example is hornblende, right? Hornblende. And next one is feldspatite, right? First one is pyroxenes, feldspar, next amphiboles and feldspatite. Feldspatite, right? So examples is nepheline and also leucite and also hyanite and also noselite, right? So these are the examples. And olivine group examples, olivine. And olivine and beryl and also garnet and also spin and also topaz, tourmaline, zircon, right? So then next one is mica. Last one is mica. Mica silicates, that is muscovite and biotite and also flogophyte. So these are the some of the pyrogenetic minerals, right? So and also we have other minerals, right? So what are the other minerals? That is apatite and also gold, hematite, chromite, magnetite, chrysoberyl, ilmenite, columbite, and also monazite, corundum, pyrite, fluorite, so etc. etc. So these are the some of the other pyrogenetic minerals, right? So next one is texture, right? So what is that texture? So the sorry. Right? Texture is the intimate mutual relationship of constituents of rock. So that is, it deals with the size, shape, nature, and arrangement of igneous rocks. So texture is best studied in this thin section under microscope rather than in the outcrop, right? So texture is the size, shape, and arrangement of mineral grains in the rock. So it can be also be described as mutual relationship. So of mineral grains and glassy matter in the rock. So texture is the best studied under, what is that? Under this thin microscope, right? Thin section. So that is 0.03 mm, right? So thin section, that is with thickness is 0.03 mm, right? So why read about this structure? So that is important thing. So the texture of a rock, that is a result of various process that control the rock's genesis and along with the mineralogy, right? Mineralogy, right? And also chemical composition and also provides information so that we may use to interpret the rock's origin and history. So it is the important for us, that is to be able to recognize and describe the textures of a rock, and that is to understand how they are developed, right? So the term texture mainly refers to that is mutual relationship of the constituent minerals that is in a rock, in addition that is to crystalline. And you see here, first one is degree of crystallization or crystallinity or crystalline, and also second one is grain size or granularity, and third one is shape of crystals, and fourth one is mutual relations of crystals and glass, right? So you remember this. So this picture of an igneous rock is described with reference to these four factors. You mind it, right? These four factors, right? So the last two, you see this last two factors are sometimes grouped together as fabric, right? So some writers or some mineralogists, so those are use the term fabric for the total physical data of both texture and structure. So already told about the structures before class. So while other use these three terms synonymously, right? So first one is, so we discuss one by one these factors. First one is, what is the degree of crystallization or crystallinity, right? First of all, you see what is the crystal and what is the glass. You see the difference between crystal and glass here. You see first one is crystal, right? This crystal, you observe this picture. This is the crystal form, right? So when the molecules in a rock have settled down into a stable arrangement, you see here some of the stable arrangement and with a recognizable pattern, so that is called, what is that? Crystal. And then next, second one is glass, right? So glass, so it is deformed state of crystallization. So that is regarded as an amorphous solid, and in a glass, the molecules have settled down into a stable arrangement without any recognizable pattern, right? So you see the difference between, so some of the molecules stable arrangement and with recognizable pattern, right? So this is without any recognizable pattern. So this is the difference between crystal and glass, right? So first one is this one. Sorry. Degree of crystallization or crystallinity. So texture based on the degree of crystallinity. So the igneous rocks, those are formed due to, what is that? Cooling and solidification of magma or lava, right? So this crystallization of different minerals, that is takes place when respective molecules in magma, that is moves to their centers of crystallization and arrange themselves in a definite some of the patterns. So if reasonable time that is available, so crystallization of different minerals that is take place from the melt, giving rise to a rock, right? Giving rise to a rock. But if sudden chilling of lava occurs, right? So this is magma, this is lava, right? So when sudden chilling of lava occurs, then there may not be any time for crystallization to take place. So under such conditions, lava solidifies as completely amorphous or glassy matter without any minerals. So on the other hand, what is that? If cooling time is intermediate, so then the resulting rock, it will be composed partly of glassy matter and partly of minerals, right? So that is depending on the nature of cooling, the resulting igneous rocks are completely, what is that? Completely crystalline, right? Completely crystalline and completely glassy and partly crystalline and partly glassy. So the preceding these three types, right? These three different types of crystallization that is gives rise to three textures of igneous rocks, right? You see what are the types based on the degree of crystallization. So first one is holocrystalline and holohyaline, and third one is hemi or hypo or merocrystalline. So these are three types of the degree of crystallization, right? So first one, holocrystalline, you see here, right? So a rock composed entirely of crystals that is said to be holocrystalline. So holocrystalline texture is characterized by deep seated or intrusive igneous rocks. So what is the holocrystalline? So the rock composed entirely of crystals, which may or may not be visible without magnification. So right, so that is called holocrystalline. So that is indicates cooling that was sufficiently slow to allow complete crystallization to occur, right? So this is the holocrystalline. So you see the examples of the holocrystalline. So granite and gabbro and cyanide. So these are the examples of holocrystalline, right? So then next one is second one, holohyaline, right? So holohyaline. So the rock which is entirely composed of glassy materials or glass is known as holohyaline. So they occur most often marginal phases of rock bodies, but may occur as lavas or as dikes and sills. I already told in structures of igneous rocks. So what is the dike and what is the sills, right? So holohyaline, so rock composed, right? This rock composed entirely of glass, right? So that is called holohyaline. So there is no crystals visible even with magnification, right? So indicates cooling so rapid that no crystal growth could occur here, right? So that is called quenching, right? So this is obsidian and also pitch stone, right? You see the glassy structure, right? Next one is hemi or hypo or merocrystalline. So when the rock is composed partly of crystals and partly of glass, composed of partly of crystals and partly of glass. And you see here, so these are crystals and glass are mixed here. Remember this, right? So the term, it is called hemicrystalline or hypocrystalline or merocrystalline, right? So this is used example rhyolite and trachyte, right? So the rock composed of both crystals. What is that? Both crystals and glass. So that is indicates a period of relative slow cooling, right? That is sufficiently. So that is slow to allow crystallization, and that is followed by quenching of remaining magma, right? So these are the texture based on the degree of crystallization types. First one, holocrystalline, holohyaline, and merocrystalline, right? So next one is grain size or granularity, texture based on granularity or grain size, right? So granularity. So this granularity deals with the absolute size of the crystals in igneous rocks, that is ranges from almost submicroscopic dimensions to crystal measurable in yards, right? So granularity, it depends on the physical condition that had prevailed during the crystallization of magma. So that is minerals grain that is occurred in different sizes. So the presence of volatiles, low viscosity and slow cooling, and also great pressure help to this grow large minerals, right? So the following textures have been recognized based on the granularity, right? Granularity of minerals. So if minerals in the rocks, these are big enough to be seen by the naked eye, right? So the texture is depends on the types of granularity. Those are pheneric or phenerocrystalline and aphanitic, right? Pheneric and aphanitic, right? So first one, you see pheneric or phenerocrystalline, right? So if the crystals are visible to the naked eye, right? You see this, remember, visible to the our naked eye, right? You are our anyone, right? Or by ordinary hand lens, the rock is said to be pheneric or phenerocrystalline, right? So pheneric textures rocks are comprised of large crystals that are clearly visible to the human eye, right? Clearly visible, that is naked eye, right? So this is clearly visible to the eye with or without a hand lens or some of the binocular microscope. right? Binocular microscope. So the texture forms by slow cooling of magma that is deep underground in the plutonic environment, right? So you see the pheneric or phenerocrystalline is further classified. You see the difference between here. So those are so this is important things in your examinations. So those are called types of crystallization, right? So you see that is pheneric, right? Pheneric crystallization that is classified by first one is coarse grain, and second one is medium grain, and third one is fine grain. So these are the very important things you remember here, right? So you see here some of the pictures is this is the coarse grain and this is medium and also fine. So you observe in your microscope, so the picture shows like this, right? This is, you see here 1 centimeters, right? So other pictures you see, okay? So these are the microscope pictures, right? So you see fine grain. This is fine grain texture, right? And this is medium grain texture. So this is coarse grain, right? So coarse grain that is greater than 5 mm, right? So coarse means greater than 5 mm, that is visible to our naked eye. You see the picture here also. And medium grain size also 5 mm to 1 mm, right? 5 mm to 1 mm. And fine grain, so that is small things here, right? So less than 1 mm, right? It is less than 1 mm. That here is, you see 5 mm to 1 mm. So 5 mm to 1 mm. This is greater than 5 mm, right? You see the difference between coarse, medium and fine grain. So coarse is very clear here. And the next one medium is, so looks like here. So the next fine is very small crystals we observe here, right? So this is the coarse is very clear, right? So some you see here some of the black color indicates mica, right? And also white and also quartz, right? So these are the pheneric textures types: coarse, medium, fine grain, right? Coarse is 5 mm greater than, medium is 5 to 1 mm, and fine is less than 1 mm, right? Okay. So pheneric is over, and then second one is aphanetic, right? So second one is aphanetic. So if the crystals are not visible, right? You see a difference between, okay. So not visible to the naked eye or by ordinary hand lens, the rocks is known called aphanetic, right? So aphanetic texture consists of small crystals, so that cannot be seen by the eye. So with our hand lens. So the entire this rock is made up of small crystals, which are generally less than, I think, 1/2 mm in size, right? So the texture result from rapid cooling in volcanic or hyperbasal. So that is environment, right? So you see the difference between pheneric and aphanaitic. So pheneric texture is, that is, it is visible to the naked eye, but aphanaitic texture, that is not visible to the naked eye. So this is the difference between pheneric and aphanaitic texture, right? So that is visible to the naked eye, and this is not visible to the naked eye, right? So, see, aphanaitic is classified by microcrystalline and cryptocrystalline, right? Microcrystalline, cryptocrystalline. So the microcrystalline, you see the difference. What is the microcrystalline? That is, individual crystals are distinguishable with the help of petrographic microscope. So, and cryptocrystalline, that is individual crystals. So those are not distinguishable with the help of petrographic microscope. You see the difference between these are the crystals are the individual distinguishable with the help. These are not distinguishable with the help of these petrographic microscope, right? So you see the difference between, this is the 1 mm, right? So 1 mm width. So this is the some of the example picture here, aphanaitic picture, right? Sorry. So the fabric. So what is the fabric? The fabric are pattern of the rocks. Those are dependent on the shapes. You remember this word? Shapes, relative size, and also arrangement of the crystal. So the fabric pattern, that is depend on shape, size, and arrangement of the crystals. So that is depend on the shape, size, arrangement of crystal. So we have learned that the igneous rock comprises of crystallized as well as nanocrystallized components, right? So the study of shape of crystals and mutual relationship. So these are between mineral grains and glassy matter, that is described as fabric. What is the fabric? Fabric. So crystals in mutual relationship. You see here, these are the crystals, this is the rock, right? So these crystals in mutual relationship between the mineral grains and glassy matter, that is described fabric, right? Fabric. So this fabric is defined as the arrangement, orientation, and mutual relationship of mineral grains or crystals or glass, right? So fabric is a non-compositional property of the rock, that is comprises of textures and structures, both, right? So this is depend on shape of crystals and mutual relationship, right? Right. Then next, shape of the crystals. Right. So texture based on the shape of crystals. So crystal forms described with reference of the development of their phases. Right. So these textures of two different kinds. So the first term as development of crystal phases, right? Crystal phases are boundary outlines, and the other with reference to the nature of the growth of the minerals, right? Growth of the mineral. So when the mineral is completely bounded by crystal phases, completely bounded. So these are the, shape of the crystals, that is three types. First one is euhydral, subhydral, and anhydral, right? So what is the euhydral? So euhydral, that is crystals are bounded by phases, right? So when the mineral is completely bounded by crystal phases, so that is called euhydral. Euhydral, right? And next, anhydral or subhydral. So when crystal phases are absent, right? When these crystal phases are absent, it is called anhydral, right? So what is the euhydral? Euhydral means completely bounded by the crystal phases. That is euhydral. So crystal phases are when absent. That is called anhydral, right? So, and when what is the subhydral? So when the only a part of minerals, only part of minerals, that is bounded by crystal phases, that is called subhedral, right? So only a part of the mineral that is bounded by crystal phases, that is called subhedral. So crystals are partly bounded by phases, right? So this euhedral, so these minerals are rather rare in our nature, right? So the euhedral minerals as seen in their some of the thin sections, that is appear with polygonal boundary, right? Polygonal boundary outline. So whereas in the case of anhedral minerals, so they appear rounded or surrounded in the thin sections, right? So this is the shape of the crystals. What is the shape of the crystals? So these three important terms, euhedral, subhedral, and anhedral, and their resulting textures that are universally used to describe relative proportion of the, what is that? Grain shape, right? So euhedral term is used for the mineral grains which possess fully developed grain or crystal outlines. So all the crystal phases are perfectly or near perfectly developed. So that is idiomorphic, right? IDIO, right? Idiomorphic or automorphic. So these are equivalent terms. So those are used to euhedral grains here, right? So panidiomorphic granular texture, right? So that is comprises majority of grains with euhedral shape. That is, example is pegmatite. Pegmatite. So subhedral refers to crystal forms with lesser partly developed crystal faces or grain boundaries. So here hypidiomorphic granular texture, right? Hypidiomorphic granular texture. So that is consist of dominantly of mineral grains with partly developed or subhedral shape. So for example, this is gabbro, Gabbro, or and granite, right? Gabbro and granite. So this hypidiomorphic granular texture is the commonest of the granular texture. So that is also called granitic because this is mostly found in the granitic rocks only, right? And anhedral. So this term is used to form for mineral grains lacking crystals outlines. So when majority of the grains are anhedral, that is resulting. So texture is known as an allotrimorphic granular texture. Allotrimorphic granular texture. So that is also called as xenomorphic granular texture, right? So for example, apatite, right? Apatite. So this anhedral texture, that is also called aplytic because this is best developed in aplytes, right? Aplytes, that is hypabasal equivalent of granite, right? So these are the shape of the crystals, that is euhedral, subhedral and anhedral, right? So the next one is mutual relationship of last one, this one. Mutual relations of crystal mutual relations of crystals. Okay, the fabric, I already told what is the fabric. So the fabric of rock, that is influenced not only by the shape of the crystals, but their relative size and their mutual relation arrangement, right? So the fabric of a rock, that is influenced, right? Influenced not only by the shape of crystals, right? But their relative size and also that is their mutual arrangement, right? So that these textures depend on mutual relations, that is classified into those things, that is first one is equigranular and inequigranular and intergrowth and directive texture and intergranular texture. So these 5 types, that is depend on mutual relationship, right? So we discussed one by one. First one is equigranular, right? What is the equigranular? So in this equigranular, so the grain size is total grain size are same, look like same, right? So that is the equigranular texture. And inequigranular texture, so in an igneous rocks, if the grain size is different, becomes so pronounced that one set of grains, that is distinctively large and associated with another set which is much finer in size. So then it is termed as inequigranular. So inequigranular, some of the types, that is okay. So you see the equigranular pictures here. So grain size are more or less same size, right? So first one is first type equigranular textures. First type is panidiomorphic. So that is most of the crystals are euhedral. You see the difference between some, most of the, you see these crystals are euhedral. And hypidiomorphic texture. So that is most of the crystals are subhedral, right? Most of the crystals are subhedral. And then next, allodiomorphic texture. So most of the crystals are anhedral, right? Most of the crystals are anhedral and euhedral, also subhedral. So these are the equigranular texture types. So these are the inequigranular. So grain size are of different sizes, right? So first one is porphyritic texture, and second one is poikilotic texture, and third one is ophitic texture, right? So usually there is a marked difference in the grain size of the rocks, but if the variation of larger to smaller is systematic and gradual, so then that is known as the aceriate texture, right? Aceriate. Aceriate texture, right? So first one is porphyritic texture. So when the large crystals are embedded or enveloped by smaller crystals or ground mass. So this is called porphyritic texture. So in this, the large grains, so those are surrounded by the ground mass consist of smaller grains or smaller glassy pod. So the large grains are termed as phenocryst. Phenocryst, right? So remember this word. So the texture is visible both megascopically, right? And microscopic also. You see here. So pheneric texture. So this is visible both megascope or microscope, right? So this porphyritic texture that is resulted due to the change in physiochemical conditions and molecular concentration and also insolubility. So this is the porphyritic texture, right? The next one is poikilotic texture, right? So when the smaller crystals are enclosed within the large ones. So that means in this structure, the larger grain that is encloses smaller mineral grains. So the larger are host or house crystals that is known as oikocryst. Remember this word, OIKOCRYST, right? crystal, and the enclosed crystals are known as crystals, right? CHADO, right? So this is the pyokitic texture, right? So these are pyokitic texture. It can be divided three types. So those are, first one is ophitic, and second one is subophitic, and third one is hyalophytic, right? Hyalophytic. So these three types of the textures you see this in this poicotic texture. So ophitic texture, so this texture is the most common texture found in fine to medium grain mafic rocks like dolerite and basalts. So the microscopic view that is exhibit that augite encloses smaller of plagioclase feldspar, and also suboptic texture. So when these crystals of augite grains, right? Augite grains, those are smaller and partly enclose the plagioclase. Then the texture is known as suboptic texture, right? And then next one is hyalophytic texture. So it is similar to this ophitic texture, but the difference is that the diversely oriented plagioclase grains, those are completely surrounded by the glass, right? So this is the difference between these three textures, right? So I think class time is up. So I will discuss tomorrow in tomorrow class. Okay.